Hello dear friends, welcome to BYJU'S Exam Prep, the comprehensive learning app. I welcome all for this particular BARC 2023 Parmanu series. Hello, good morning sir, Arun Kumar Kanujia. Hello, good morning. Okay, and in this daily practice paper, today we are going to talk about or we are going to solve problems on algorithms. Okay. And this is about me, myself, Sridhar Dhulipala, having 20 plus years of teaching experience, and I am associated with BYJU'S from past 2 years. And you can join my Telegram group link, which is given here, for regular updates about my classes on YouTube app and also notes, right? And you can also join my Facebook or Instagram handles, my dear friends, right? And we are starting this GATE 2024 fundamental series for the students who are aspiring for GATE 2024. See, we should always start with the fundamentals instead of starting with, complete series. We are starting with the fundamental series, which is very, very important. The basics, the prerequisites one student should know before actually starting their preparation. So we are coming up with this general fundamental series for you people. It will be starting from 1st March. I think today only we are starting. So the updates will be given to you soon. Stay connected, subscribe to our channel and press the bell icon. So let us start problems, Babu. First question. Which of the following is correct? If the functions are arranged in ascending order of their growth, which of the following is correct? See, my dear friends, this is a very, very simple basic question. Okay, this will test whether you know very, very basics or not, and mostly other than GATE, any other examination, they test your basics. Okay, so you can once you prepare for GATE examination, that is the level for almost all the examination. There may be some examination like TAFR where you may be having little some topics, not all, some topics you need to put little extra effort, because that is for research oriented organization. Obviously the type of questions would be little research oriented questions may be asked. Otherwise, if it is BARC or ISRO, or even you can go for UGC net, all these papers generally the questions will be of very, very basic type. Okay, those who prepared well for GATE examination, that is the maximum level. Okay, so you can expect level less than that or equal to. Please answer the question, sir. No one is answering. What happened? What is the answer? It's a straightforward. You know that constant is always asymptotically smaller than log n, is always asymptotically smaller than n, is always asymptotically smaller than n log n. Okay, very good, Shyam Babu. Super. Shyam always on target. B is the correct answer. Super. 1 mark for Shyam. The next one. Arrange the following functions in increasing asymptotic order. In increasing asymptotic order. The next question. Always remember this idea. Log power an is asymptotically smaller than n power b, is asymptotically smaller than c power n. This is the basic order. This is the basic order one should never forget. Am I clear? Here A, B are positive real numbers, whereas C is positive real number greater than, not greater than, equal to, it is greater than 1. A, B should be positive, whereas C is positive real number greater than 1. So as long as this condition is satisfied, as long as this particular condition is satisfied, this is the correct order. So generally people feel that F is larger than H, but that is wrong. Log power 10n is smaller than n power 001 also. Okay. n power 0.001 also dominates log power 10 answer. Okay, remember that is the rule which I given. That is the rule. Am I clear? And this would be smaller than 1.01 whole power n. So the correct answer is G. I'm sorry, H is the smallest, then F, then G. B is the correct answer. B is the correct answer. See, my dear friends, we should not see for small values of n. This is for very large values of n. This result is very large values of n. Under marathon series, I discussed all these concepts again. Okay, we especially at the time of gate examination, we come up with many okay, very big numbers, okay. So you can fix a c value, and see it is not less than or equal to, sir, it is, asymptotically. Okay, asymptotically larger or equal. Actually strictly larger only it is. Strictly larger only, my dear friends. Of course, you can use the limit formulation to verify that. You can use the limit formulation to verify that. You can take limit as n approaching infinity. Fn by Gn, you can find it. If it tends to 0, okay, that means G is larger. That is, Fn is asymptotically smaller than Gn. Fn is asymptotically smaller than Gn. Suppose if it tends to infinity, Fn is asymptotically larger than Gn. And if it tends to a finite value, non-zero finite value, then Fn and Gn are of same order of growth. Fn and Gn are, very good, sir, good morning. Fn and Gn are of same order of growth. So please note that point, my dear friends. With the limit approach also you can solve this problem. So B is the correct answer. So 1 mark only so far. People got. Next question. Let f and b be the functions of natural numbers given by fn is n, gn is n square. Which of the following statement is are true? Which of the following statements is are true? What about the answer? C. F is small o of g. Very good. See, my dear friend, f is asymptotically smaller than g. So whenever it is asymptotic, because n is smaller than n square, na? It is n and it is n square, therefore f is small o of g. So you can write equal to, or you can write belongs to, both are one and the same, my dear friends. Whether you write equal to or belongs to, both are one and the same, my dear friends. Both are one and the same, my dear friends. Hope you understand. Very good. Next question. See, sometimes you also get the direct questions, Babu. Note that point. Sometimes you also get the direct questions in the gate exam. I mean, in such examinations. It should not take much time. They're all very simple. See, there are around 18 questions. I think mostly, because one question is already gone wrong, mostly 16, those who prepared decently for gate examination, 15 to 16 very easily you can score. Yay, very good, straightforward question. You know that binary search for sorted array takes how much time in the worst case? This is the worst case. See, some people ask me, sir, time taken is given but worst case is not given. But by default, when you say time taken, we always talk about worst case time only. So default is worst case time complexity. So the worst case time complexity is this one. So this is the correct answer, my dear friends. This is the correct answer. Very good. Next one. Even this is a straightforward question. Straightforward question. Next one is also very straightforward question. Please be careful. Sham, correct only, na? Check once. So the correct answer, see, for merge sort you can remember that whether it is best case, worst case or average case, always the time complexity of merge sort is given by, what is the time complexity of merge sort? 2tn by 2 plus theta n. So by master theorem you can always verify whether it is best or worst or average case. Always the time complexity is theta n log n, my dear friends. See, given big O, whether you given big O or theta, it is one and the same, my dear friends, in this case. Next one. The worst case time complexity of quicksort is, even straightforward question. Straightforward question. Order n square. See, some people always have this particular confusion. It's a very simple question. See, my dear friend, worst case is order n square, but most of the time quicksort works in its average case. That is the speciality of quicksort algorithm. Mostly, generally, if it is a sorted array or reverse sorted array, okay, or all elements are equal, in such cases quicksort generally works in a worst case, order n square. But most of the time quicksort takes its average case. Wonderful. Good. Next question. This has to be solved, sir. Please solve it. If you are having idea about Huffman tree, simple problem. It takes at least 2 minutes time or 1 plus minute. If you solve quickly, you can do it in 1 minute, but leisurely if you do it, maximum 1.5 minutes you can do it. But take that 1 minute time leisurely. Don't do mistakes. You can try this or you want me to solve it? Please tell me that. See, my dear friends, when you are going for Huffman tree, you have to first arrange these fellows in ascending order or non-decreasing order. I am explaining. This is a very straightforward. Whenever a Huffman tree problem asked, you can always try this method, my dear friends. Okay. Now look at this. Smallest is point. See, this is A, this is B, this is C, this is D, this is E. So smallest is B. So let me write this once again. A, B, C, D, E. A is 0.17. B is 0.11. C is 0.24. D is 0.33 and E is 0.15. So first you have to take, you have to arrange them in non-decreasing order, that is increasing order with equal fellows together. So smallest is 0.11, next smallest is 0.15, next smallest is 0.17, next is 0.24, next is 0.33. So these are all leaf nodes. So I just keep them like as it is. So what we do is we merge the smallest leaf nodes into, that is, we create internal node using these two leaf nodes. So how to merge them? You just add them, 0.11 plus 0.15, which is 0.26. So this is the created one. Now again, what you need to do, again you have to arrange them. So when you arrange, it is 0.17, 0.24, okay, then 0.26, then 0.33, okay, and this 0.26 is created one. The created ones I keep it in circle. Next, 0.17 and 0.24 are smaller ones, so you merge them, and this internal node cost would be sum of these two costs, that is nothing but 0.41. Now again arrange them, so I think it is 0.33, so 0.26 created one, 0.33 and 0.41. So this is created. Now you merge these two fellows. So again you get another internal node, which is nothing but 0.59. Now again you arrange them. 0.41 is smaller than 0.59. Then these two are created fellows. Merge them and you are going to get 1. Now you completely draw this. See, I am doing it in parts. Now we try to completely draw this. See how 1 is created. 1 is created from 0.41, which is a created node, internal node we can call it, and 0.59, which is also internal node. How 0.41 is created? It is created from both. It is created from both leaf nodes. How 0.59 is created? It is created from one internal node, which is 0.26, and one leaf node, which is 0.33. Very good. Then 0.26, how it is created? 0.11 leaf node, 0.15, my dear friends. Is the idea clear? Now, this is your 0.17 is A, then 0.11 is B, 0.24 is C, 0.15 is E, and 0.33 is D. So you just write left node is left edge is labeled with 0, right edge is labeled with 1. 0, 1, 0, 1, 0, 1. So the label or the Huffman code for A is 0, 0. Huffman code for B, C is 0, 1. Huffman code for B is 1, 0, 0. And Huffman code for E is 1, 0, 1. And Huffman code for D is 1, 1. See, the one with high frequency will be nearer to the root node. The ones with low frequency will be far away from root node. Now you need to find the Huffman code for this fellow. What is that? 1, 0, 0. Then 3 zeros. Then 1, 1, 0, 1. So if you start here with 1, okay, 1, then you want 0, then 0 here, then you want 0 here, 0. So this 1, 0, 0 represent B. Now single 0 we don't have anything, but double 0 we have, that is A. Then with 0 we don't have anything, but 0, 1 we have C. Then we have 1, 0, 1 we have E. So it is BACE, my dear friends. BACE. BACE. So earlier you given wrong answer. I think you corrected your answer, my dear friend. BACE is the correct answer. C is the correct answer. That is your Huffman code, my dear friends. Okay. The next one is a good question. Very good question. Now let us solve this problem. M1 is W by X matrix. M2 is X by Y matrix. sorry, and M3 is Y by Z matrix. Okay, Shyam says C, Tamil Selvi says D, let us see. Okay, now if I do multiplication in this order, M1, M2 followed by M3, let us see how many multiplications required. If I do multiplication in this order, M1, M2, M3, let us see how many multiplications are required. Okay, so first you have to multiply these two fellows. You get some intermediate matrix, let us call it as A, and this fellow's order would be W by V, W by Y, and for that we require WXY multiplications. Now M3 is Y by Z matrix, so again if you multiply these two fellows you get final solution matrix, and whose order will be W by Z, and for this we require how many multiplication? WY Z multiplication required. So the total multiplications required would be this plus this, that is WXY plus WYZ. If I do this multiplications, suppose if I do the multiplications for this in this order, first you may multiply, you may get some intermediate matrix of order X by Z, and it requires X by Y into Y by Z, means it requires XYZ multiplications. Then you get the final solution matrix whose order would be W by Z, and if you multiply W by X with X by Z, how many multiplications required? WXZ multiplications are required. So total number of multiplications required here would be XYZ plus WXZ. What is that you want, sir? You want this multiplications or that this time to be less than this time. So this number should be less than this number. So try to find the condition for that. What you do is you divide throughout by WXYZ. So if you divide throughout by WXYZ, what happens here? WXY get cancelled and you get 1 by Z. Here WYZ get cancelled, you get 1 by X. If you divide by WXYZ, XYZ get cancelled, you get 1 by W. Here WXZ get cancelled, 1 by Y will remain. So what is the correct answer? I said na, good question. So it requires little work. B is the correct answer. B is the correct answer. Is the idea clear? Is the idea clear? Nice question. See, this type of questions will actually, see, generally I always tell applying the rule, applying the concept. Concept is not different. Same thing what we do regularly. Okay, which order you want, you can just check multiplications. But if you want this to be less than this, that is all elementary mathematics. This you do in your 10th class level. Less than means what conditions should be satisfied. Next question. If an array A contains the elements, items 10, 4 and so on in that order, what will be the resultant array after third pass of insertion sort? Third pass of insertion sort. After third pass of insertion sort, what will be the answer? Very good, Shiksha Pandey, super, very quick. So when you do the insertion sort, for this particular array, first element, first pass will be just as it is, so single element, no problem. But the second pass you are here, you have to keep this particular element because here the pass actually starts from here. This element has to be placed in its correct position. So you check Whether 10 is larger than 4, yes, you have to move left, no further element. So 4 will come here and 10 will go here. 7, 23, 67, 12 and 5 as it is. Now next you are here. See, always you are seeing up to here. See, it's like insertion sort, up to here it is sorted. It's like, you are playing cards, you got a new card, you try to place that new card in its correct position. That is the idea of insertion sort, nothing more than that. 7 is large, 7 is smaller than 10, yes, you move left. 7 is larger than 4, so you just move 10 to the right. So 7 should come here and 10 should go here. 23, 67, 12 and 5. Second pass is completed. Now the third pass, 23 is already larger than 10, so that will stay there only. That will stay there only, and this is the correct answer for this, my dear friends. So B is the correct answer, as you all solved it perfectly. You all solved it perfectly. See, please note this. After few passes of a particular algorithm, what will be the resultant array? That kind of questions you can expect, my dear friends. Okay, please note that. Practice that all sorting algorithms and practice their complexities, my dear friends. Please do practice their complexities perfectly. The next one, what is the time complexity of this particular code segment? What is the time complexity of this particular code segment? Log n, Shiksha Pandey says, very good. Sham also says log n. But there is a trap in this problem. N value is x, which is 10. That is, n value is 10. So here, this loop goes up to 100 only. So when the loop goes up to 100, okay, whether you go log 100 or whatever it is a constant time complexity only. So the correct answer for this is option D. The correct answer for this is option D. Very good. The next problem. What is the time complexity of this code? C. Very good. Here no trap. This, how many times it iterates? N times. How many times it iterates? Whether it is j into 2, j into 3, as long as it is constant, it iterates log n square times to the base 7 maybe. But it is equivalent to 2 log n. Asymptotically, you can say log n only. Asymptotically, you can say log n only, my dear friends. Okay. Now this is n and this is log n. So the time complexity for this is n log n, my dear friends. Very good. Most of you given correct answer. The next one. C. See, my dear friends, here we have outside while loop, inside for loop. So first time when n value is n, the for loop iterates up to n. That is the for loop iterates n time. Next n value is updated to n by 2. So for loop iterates n by 2 times. For next time it is by 2, that is n by 2 square, the for loop iterates n by 2 square times. So how long it will continue? Okay, maybe in the kth term. See, kth term means n by 2 power k minus 1. Okay, n by 2 power k minus 1, that is when n is equal to n by 2 power k minus 1. So in this particular case, the for loop iterates n by 2 power k minus 1, n by 2 power k minus 1. So we can assume that this has to be up to that particular one you are going to iterate, my dear friends. Next time what happens, it becomes 0 and you come out of the loop. Next time what happens, because if you take n by 2 power k is equal to 1, okay, so what happens, the for loop value n by 2 power k plus 1 somewhere, if it is n by 2 power k minus 1, if you assume equal to 1, when n by 2 power k, it would be 0, obviously you come out of the loop. So this value will be, how many times it iterates, n plus n by 2 plus n by 2 square plus and so on n by 2 power k minus 1. Taking n common, this is 1 plus 1 by 2 plus and so on 1 by 2 power k minus 1. Am I clear? So here this is nothing but geometric series. Sum to k terms is given by 1 by 1 minus 2 power k by 1 minus 1 by 2. That is nothing but this half will convert into 2n. This is 1 by, see here 2 power k will be n by 2. 2 power k will be 2n. Sorry, because 2 power k minus 1 is n, means if you want 2 power k means you need to multiply this with, okay, I'm sorry, 2 power k. 2 power k will be 2n and 1 by 2 power k is equal to 1 by 2n. So what happens, it is 1 by 2 power k, which is nothing but, I think I am covering it, sorry, 2n into 1 by 1 by 2n, and whatever it is 2n minus 1, which is of order n. So order n is the answer for this. Order n is the answer for this, my dear friends. Order n, not n square, order n is the answer for this. Okay. See, generally the confusion is generally we use j, no. So instead of j, he used that particular, that is the difference he stated. Generally they take j is equal to n and j is equal to j by 2, it would be easy, but n, same n value they use, so that created little confusion for this particular problem, sir. Am I clear? Otherwise it is a regular problem. Good question it is also. Oh, so for those who are having difficulty with master theorem, a quick recap of master theorem, and a good number of questions they are asking direct questions from master theorem in this kind of examinations. Direct straightforward master theorem questions only they are asking. Tn is equal to a Tn by b plus Fn. So here we generally take the computation between n power log a to the base b versus Fn. Suppose if this is dominating, then Tn is theta of n power log a to the base b. If both are of same order, you just need to multiply this with log n. You can also write theta Fn into log n also. Fn into log n also you can write. But when Fn dominates, you have to check what is known as this regularity condition. But when it is a polynomial or generally exponential kind of functions, generally this regularity condition will be satisfied. So whenever it dominates, theta Fn is the answer, but provided the regularity condition is satisfied. Okay. What is the answer for this? What is the answer for this? Very good. So here A is 3, B is 2 and Fn is equal to n square. Consider n power log 3 to the base 2 and it is log 8 now it is it's taken 8 log 8 to the base 2 which is nothing but 2 cube, that is nothing but n cube, whereas this is n square. So when you compare these two fellows, obviously n cube dominates, therefore the time complexity is theta n cube. Straightforward. Very good. Straightforward. The next one. The next one. What about this? Here n power log 1 to the base 2 versus 2 power n. Obviously it is n power 0 constant and it is 2 power n. You can also verify regularity condition. This is dominating. You can verify regularity condition. Tn is equal to theta 2 power n. That is option D, my dear friends. Because here 2 power n dominates, D is the correct answer. Very good. Straightforward questions these are. The next one. The next one. Very good. Both are of same order. N power log 2 to the base 2, which is nothing but n, and Fn is n. Both are of equal order of growth. Therefore, Tn is theta n log n. Theta n log n is the answer. Very good. Let us conclude with 3 more problems. Very good. Very good. So, there is a graph is given. Which of the following is not depth first traversal? Which of the following is not depth first traversal? So, depth first traversal, on a given opportunity we directly go to the next level. On a given opportunity we directly go to the next level. Raj Tiwari says B is not breadth first traversal. Very good, sir. Very good, Raj Tiwari. Nice, Sam. Very good. So you start at A. Let us see option A. You start at A. You can go to B. From B you can go to E. From E you can go to G. From G you can go to H. From H you can go to F. So A is possible. But if you take B option, from A you can go to B, and from B you can go to F, but from F you cannot jump to E. That is not possible. So B is not possible, my dear friends. B is not possible. You can verify the other fellows like C and D are possible. A, B, F, H, G and E is possible. Then this one is A, F, G, H, B, E. That is also possible. Very good. What is the minimal weight of minimal spanning tree of the following graph? Weight of the minimal spanning tree. Raj Tiwari, you know the answer or what? Solved very quickly. So you can take smallest weight. Smallest is 10. Can be selected. Okay, next, because all are distinct weights, okay, the spanning tree will be unique. 15 is selected. Next 20. Next 25. because there are total 6 vertices. 5 edges if you select, the story is end. Then after 25, 30 you cannot select it because 30 forms a cycle. Can you select 35? Yes, 35 can be selected. So this is 10 plus 20, 30 plus 25, 55, 60, 70, 105. 105 is the correct answer, my dear friends. Very good, very good. I understand. You can also try Prim's algorithm for this, my dear friends. Even you can try Prim's algorithm starting from any vertex. So starting from A, create a cut. This is selected. Then AB, you create a cut from AB. Out of all this, what is the smallest edge cost? 25 is the smallest edge cost, select it. Then you try to create a cut from AB's F to other, ABF to other vertices. Why it is not selecting? So you can select cut from this to other edges. Am I clear? So in the 30, 20, 15, 15 is the smallest, select it. Then you have to identify the edges reaching the last vertex, that is E. What are the edges which are reaching E? All these edges. Out of which one is the smallest one? 35 is the smallest one, select that. So you can also use Prim's algorithm to get the answer quickly, my dear friends. Very good. Anyhow, the answer will be 105. Please practice this Kruskal, Prim's, BFS, DFS algorithms. They are very, very important for such examinations. I think this is our last problem for today's session. Okay, hope you enjoyed the problems. And generally, as I told you, for this type of examination, gate level or less than that. Maybe one or two special problems may be there, but those who prepare for gate level, obviously you can handle that, my dear friends. Now this is a very regular problem. Please handle this problem, Babu. I want all of you to handle this problem carefully. This is the hash table. Okay, the size is mod 7 means total 0 to 6. The numbers which are hashed to 0, the numbers which are hashed to index 1, hashed to index 2, hashed to index 3, index 4, index 5 and index 6. Oh, you already answered. Very good. Where 18 is hashed, you have to see. 44 means 44 percentile 7. Reminder, 44 is 2. So 44 is mapped to this. 45 reminder is 3 mapped to third index. 79 means 2, but 2 is already occupied and you are using linear probing. So 44 occupied means next vacant location, that is also occupied next location. So obviously for 79 will go to fourth location. 55 means 6 because 55 percentile 7 means 6. Sixth location is very happy. 91 maps to 0 index because 91 percentile 7 is 0. 18 percentile 7 is fourth. Fourth index is already having element, so collision will be there, so it will probe to the next location, that is 18 will go to the fifth location. So which location? 18 will go fifth location. See my dear friend, that is about the problems, and you are having this free workshop by Richa Gupta ma'am and how to ace gate 2024 with college as well as those who are doing job. It is on 2nd March, that is tomorrow at 7:30 p.m. on BYJU'S Exam Prep app. So the complete details will be provided by Richa ma'am. Okay, please do attend this session. Then you can subscribe to our BYJU'S Exam Prep app. Not only here, even in your BYJU'S Exam Prep app, now I am currently running this particular concept builder series, algorithms. Today and tomorrow I will be discussing, today I think I will be discussing problems on time complexity. So please do attend, my dear friends. So it will be provided in your Telegram group, my dear friend. Please do join my Telegram group, CS_Sridhar. There I'll provide this particular PDF, Babu. Okay, and it would be password protected. The password for this particular PDF is algo 3. Algo 03 is the password. Algo 03 is the password. Right? That's all for today. Thank you. Thank you all. If you have any doubts, you can ask me. Otherwise, I'll call it a day. If you have any doubts, dear friends, you can ask me. Any doubts, you can ask me. General doubts, any subject related doubts, anything, open to you. If no doubts, then we call it a day. Jai Hind. Thank you.